All right, so this is the second video in figuring out the equation of an exponential function from a table. So the next two examples that we're going to look at are not terribly difficult. You just got a little bit more thinking that you've got to do, okay? So when we look at this table, we see that the x values are all going up by 1. We see that the y values are increasing as well. So this table is showing exponential growth, okay? Now, let's figure out what we're changing by, okay? In an exponential function, you're changing by multiplication, always. So we've got to think 9 times what is 27? If you're not sure, think of it the opposite way. 27 divided by 9 gives us what? 27 divided by 9 is 3. So what that means is that 9 times 3 gives us 27. So 27 times 3 would give us 81. 81 times 3 is 243, so on and so forth. So our factor, our b value here, is 3. That's what we're multiplying by each time. Now, when we make an exponential equation, we've got to have the y-intercept as well. So we've got the part for b, we've got the number that has the exponent, but we don't have our y-intercept. Now, a y-intercept occurs where x is 0. I'm going to erase this right here. So we've got to think then, the table, the first x value that we have is 2. But we notice that, okay, as the x's are going up, the y values are going up, multiplying by 3. So we've got to think then, if we were to extend the table backwards, okay, think, instead of multiplying by 3 to go up, we could do the opposite. We could divide by 3 to go backwards. So 9 divided by 3 is 3, and then we need to take the table one step further to get to where x is 0. 3 divided by 3 is 1. So our y-intercept is 1. So when we make our equation, we'll have y equals 1 times 3 to the x power. But multiplying by 1 doesn't change anything. So we don't even really need to have the 1 or the parentheses. We can just say y equals 3 to the x power. All right, so let's do one more like that, guys, okay, where the y-intercept is not shown. So on this one, our x's are increasing by 1, like we need them to. Our y values, though, are decreasing, okay? So this function, this table is showing exponential decay. The y values are going down while the x values are going up. So let's think about, let's take a moment and we'll think about it using division at first, okay? And then we'll rewrite it in terms of multiplication. So on our y values, if you're not sure 243 divided by what is 81, find numbers where you do know. So we know that 9 divided by 3 gives us 3. We know that 27 divided by 3 gives us 9. So what we're really doing here is dividing by 3 each time, okay? Or instead of dividing by 3, think of it as multiplying by 1/3. They mean the same thing, okay? Now, we don't have our y-intercept in this table, okay? But we see the x values, they begin at -5 and they stop at -1. So we need to continue that pattern just one step further to get our y-intercept. So 9 divided by 3 gave us 3. We can divide by 3 one more time to get the y value when x is 0. So our y-intercept here is 1, and our b value, the number that we're multiplying by each time here, it's not going to be that 3 because that 3 is division. but dividing by 3 is the same thing as multiplying by 1/3, so our b value is 1/3. Then when we make our equation, we'll have y equals 1 times 1/3 raised to the x power. But like on the last example, multiplying by 1 doesn't change anything. So we're just going to say y equals 1/3 to the x power. And it's just assumed that that 1 is in front. Typically when the factor or your multiplier, whichever term you're thinking of, whenever it is a fraction, we normally do keep it in parentheses, okay? So those were kind of some medium level problems. Now we're going to end this video and then we'll do a couple of examples that are a little more advanced, okay?